Okay, how's everybody? And testing, testing. All right, hopefully people can hear me now. And hang on, I want to find. Okay, working. All right, if everybody can hear me, then we're in good shape. All right. Uh, Hang on, I need to get OBS back in front and make it smaller. My apologies for how confused this is. Um, all right. Okay, I have. So, how many of you have started on the constraint logic programming under finite domains stuff? I am waiting for that question. Okay, great. Great, great. I was concerned. It's been a very quiet week. Um, I suspect that about half of my students, about 60% of you, are in the United States, um, and even those of us who aren't, it's been a weird week for the world, and also uh, we're all struggling to keep up to the end of class, and working on swish problems now. The train problem is taking some time. Uh, Great, great. Um, I suspect you're all just getting a lot more independent as well. So, okay. Uh, Prolog is typeless. How many people here have kind of went, I don't know, this is a typeless language? Uh, so, um, so it is indeed typeless. However, Prolog has dispatch, has all this cool logic-based dispatch, and uh, all of this unification-based dispatch, and that means that sometimes you can do things that look an awful lot like types. Okay, now my perennial example, my mother's height. Uh, how tall is my mother? And I'll take my questions on the Slack chat. So, how tall is my mother? Anybody there? Yeah, did I start? I seem to recall. This is in the video. If you've watched the video, I think this is in there. But I always want to start with this because it's such a great example. Yeah. Okay, we know one thing about my mother's height. We don't, well, first of all, we don't know my mother's height, or you guys don't. I'm presuming you've never met my mother. So, um, so we would measure her height, and we're going to have to agree on what we measure it in. So let's agree centimeters. And and is that all we know about my mother's height? Do we know anything else about her height? Yeah, okay, it's between the shortest person and the largest person. So, yeah, 120 to 250. And you can pick exactly what those values are, but right. Okay, so what we have is a domain that my mother's height is restricted to. Um, so, uh, and we can surprisingly often make these kinds of restrictions uh, on values that we don't yet know. For example, anybody want to guess my public IP address? Well, you probably don't know my public IP address. You probably figure it out somehow. Uh, but um, but I bet you it's not 192.168.1.255. Uh, so I bet you it's not 127.0.0.1. So we can put constraints on uh, on answers. And this looks much like, and this can look much like a type system. It can also be used to do computation. Norbert's talking. So I think I'll keep talking till I see it up here. So, okay. So if I can say use module library CLP FD and now I can say things like X is in the range 5 to 10. And Y is in the range 7 to 14. And X, and let's see what happens. It tells me those two things I told it. But now let's try something else. Let's try telling that X is more than Y. So wait, it's smart enough to figure out that X has to be in 8 through 10. and that y has to be in 7 through 9. In fact, it's a little smarter than I am. I was kind of expecting y to be 7 through 10, and oh no, because x has to be more than it. So we can start setting up problems and reducing them. I'm going to work through a classic example, the send more money puzzle. The send more money puzzle is this. You write send plus more equal money, and then you are to assign values to the letter, digits to the letters, such that when you write them out as numbers, that is, if S is 5, it'll be 5,000 and something. If E is 4, then an N is 3, and D is 2, then it'll be 5,432. So that this is a true statement. Okay. So we have only SEND, MOR, and Y. Those are the variables. And I'm just going to put them in a list so that they're easier to manipulate. Because we often want to constrain a set of variables to the same values, to the same domain, there's a convenience. I can say ins, INS, and is this big enough? Should I blow that up just a little more? I can say ins, and that will constrain all of them. That will constrain S, E, N, D, M, O, R, and Y, each to be within 0 through 9. Okay. I'm then going to insist that they all be different, and there's a built-in helper for that. And then I'm going to insist, and this is poorly indented for some reason, there we go. That send S times 1,000 plus E times, so that's whatever number send is, plus whatever number more is going to be equal to whatever number money is. And then there's two other restrictions. It makes no sense to have the 0 on the front. So neither S nor M is 0. Yeah, okay. It was invented so the same place. Oh, sorry. There we go. Okay, well, I'm not going to worry about it. And then and so if I run this way, it's going to tell me hang on, I forgot to consult. Okay, it's going to give me a whole bunch of constraints. So this isn't all that useful in most circumstances. What we really want to do is know some solutions. So, okay, instead, Yeah, now it gives me what I want. And it turns out there's only one. So how's that happen? Well, label is going to find a value. It's a non-deterministic predicate that finds a value that satisfies all the constraints for each variable in the past list of variables. And so that's going to ground things for us. Okay. How are people doing? Is this making sense? I'm kind of talking to people at different places on figuring all of this out. So I wanted to show this simple example and then go on to something more complicated. So everybody, please give me some baffleometry here. I'm seeing one thumb up and one emoji that didn't resolve. And okay. Baffleometry is high, but not too high. Okay. All right. So, yeah, okay. Well, that's this week's assignment is CLPFD. We're going to use my tutorial on pathways, and I've made you guys a special video, and that kind of explains some stuff, and then asks for an assignment. Okay, so why don't we work a simple example together? I have a chemical tank. And the chemical tank is in one of three stages. The chemical tank is in startup mode. Is pressure less than 100. Run mode is the pressure greater than or equal to 100. In startup mode, the temp A and in startup mode, the temperature must be held between 150 and 250. In run mode, it must be between 250 and 400. Okay? All right. So let's build a little constraint that says that our chemical tank is operating properly. And the pressure will come in. The pressure will be provided to you. Okay, so anybody have any ideas how we can go about this? Comments? Okay, we're going to have an operation. Pressure and temperature. Okay. I have a call for temperature in 150 to 250. But that should only hold okay. We should. Werner says, shouldn't we have a variable for the mode we're in, startup or operation? Yes. Startup is defined as the pressure is under 100, and run is otherwise. So we need to get the pressure involved some way. How could we can make something that's constrained based on which mode we're in. Yes. No, it would not, because that implies that you're simply going to demand that the pressure be less than 100 and the temperature in 150 or to 250. Now, maybe you can combine that with an OR and get where you're going. that just bucks the problem. If you, somebody's got to decide whether we're in startup mode. And the problem here is we really want to make this a constraint. We really don't want to test the pressure now. We want the pressure for all time, in a sense. Either the mode or the required temperature. Yep. Okay. Do you guys remember reification? D.V. Burkle's not too far off. Pressure okay, that's true. That'll succeed. That'll be happy as long as we're in startup mode. So we could do this. $250 through 400. Okay. We could do that. That does the job. It's a little awkward. It doesn't really express what we wanted. Let's try it though. Yes, that's actually an excellent strategy if you are going to need to do that. But again, we want to be in constraint world. Okay, so let's think about how we can do it. So, do you guys know this operator? This is single implication. If we rearrange this, we can make it much closer to the problem statement. If the pressure is less than 100, that implies that the temperature must be in 150 to 250. If the pressure is greater than 100, it implies the temperature is 250 to 400. And that's a much clearer one. Now, you guys were talking about using a variable. Let me show you a great trick here. Let's have a second version and into which I will pass the mode. Now, let me show you a great trick. I'm going to make this operation to underscore, because, of course, we have to build the mode. Well, one way of doing this would be to have the mode be 0 or 1. So I could do something like implies that mode pound equals 0, mode pound equal 1, and operation to underscore mode pressure temperature. Okay, and then we have to do something with mode. But let me point out, this is Prolog, and these things are actually just terms anyway. So bizarrely enough, there's something sneaky you can do here. Pressure. The pressure is 100. Sorry, it's this one. And now we don't actually have to have the pressure here, because we're only interested in the pressure to know what mode we're in. Okay. So now we have a constraint pressure and temperature and it properly constrains it. Let's go back, set the pressure to something else, and it constrains it. Oh, I call that operation 2. Okay, and that was operation. And now let's find out if operation 2 works. Whoop. Let's try that again. Okay. Turn it down below the constraint, and we get the right behavior. Okay. So you can control constraints with constraints. All right. Well, that's that one. I thought I would walk through. Okay. I think I can walk through this. I don't know. Might be a little advanced for this, but all right. Before I do that, I was going to ask anybody who's gone through the tutorial and looked at the tutorial is mostly a list of is mostly an explanation of the predicates, because I found them baffling, reading the documentation. So I said, well, I will make a tutorial out of this. Is there anybody who found this baffling? found some of these baffling and wants me to explain some of them. Yes? Okay, if you do, tell me which one. Automation 8. um, automation. Automation is uh, automation basically lets you write a finite state machine and then say the sequence of elements must, in the list, must be something that you can traverse in the finite state machine. So, people here know about finite state machines? Let's work one. Okay. All right. Let's have a finite state machine. Hang on. I have YED already running. So, okay, let's make a finite state machine. And call that A. Sorry for that being small. And it'll be B. Hang on, I tell you what, while I get that up. Okay. All right. Okay, I've got A and B. A to the n, B to the n. You can't recognize A to the n, B to the n with an automaton. That requires a push-down stack acceptor. A push-down acceptor. Yeah, you cannot accept that with a with an automaton. You probably can. As I say in the example, automaton 8 is on hold until I understand it. Automaton 8, I believe, allows you to have some push down stack acceptor. But honestly, I'll tell you, I don't know. I know how the single, I know how the automaton, um, automaton 3 works. Automaton 8. Oh, automaton 8 allows counters. Okay. But honestly, guys, I tell you what, I am going to have to get back to you on that because this is the one that I could never figure out when I wrote this thing, is how the heck the counters work. So, all right. Okay, well, if you guys are asking about that, then yeah, if you truly are asking about Automaton 8, I thought you were asking about Automaton 3. Automaton 8 is, it's unclear to me exactly how one is supposed to use it, and yeah. Good luck with that. You'll have more luck than I will. So, okay. If you can figure it out, good luck. I could probably have another go at it, but you know, I'm just a Prolog programmer. So, okay. I think we can do this. All right. You all have seen the wolf, goat, and cabbage. I used S for sheep here, but yep. I have stared at that and it was unclear, which is kind of too bad. Marcus is actually a very clear writer. Oh, by the way, it's Dr. Trista. But Marcus is usually a very clear writer, so. Okay. So, this is a somewhat more hand-wavy example. I'm going to try and solve by now, you've already seen it, problem of wolf. This one's wolf, sheep, and cabbage, but I may call it a goat. As a, and the way I'm going to do this is I'm going to make a list. And each element of the list is itself going to be a list of 4 things. And those 4 things are going to be the farmer, the wolf, the sheep, and the cabbage. And the and there'll be 0 if they're on the left bank where they start, and 1 if they're on the right bank. Okay? So, but rather than like simulate the farmer, what I'm going to do is I'm going to simulate the motion. I am going to set up constraints between one state and the next state, and then I'm going to fire the whole thing off. So, if I say go, it's going to give me a solution. And of course, there are a number of solutions here. All right, so let's look at this thing. So, bizarrely, I am going to pass this thing down and then bring it back up. This is pretty much your standard assemble on return thing, right? I'm going to get a set of variables, or a nested set of lists, and all I really want to do is be able to label all of the variables. So what I'm going to do is I'm going to flatten the list so I have a single list, and then I can pass that to label, and it will do the labeling. Okay, so how do I set this up? Well, I'm going to talk about the base case last, because in this case, the base case is the most mind-blowing. All right, so I have a move that has come in. This is the most recent move, FWSC. And then, of course, this is the previous moves. And I'm going to make a next move, whose values I don't know yet. And I'm going to take, all the next move variables have to be in 0 or 1. Those are the only ones we're interested in. We move the farmer every time, right? The farmer, if he's on the left bank, then on the next move he's on the right bank, right? Because he's got to paddle about. And then I'm going to have a maximum. Now, the rule about being only able to carry one thing is the same as saying that the other two things must remain in place. So the new position, either the new position of the wolf has to be the same as the old position, and the new position of the sheep has to be the same as the old position, or the sheep has to stay in place and the cabbage has to stay in place, or the wolf and the cabbage has to stay in place. Okay? Now, there are also a couple of other rules, and that is that that if the sheep and the cabbage are the same, then the farmer, that implies that the farmer, if the sheep and the cabbage are together, then that implies that the farmer is with them, right? This is reification again. If the wolf and the sheep are together, then that implies that the farmer is with the wolf. Okay, so I've just set up constraints on the next rule. Well, this is fine, and I'm building up this list of constraints. You can see here I have used, remember you can use a comma and actually add two things on the front of the list before the OR bar. And you can add as many as you want, but I've got two here because I need to re-add the previous move since I destructured it out. And then I'm going to have to add the new move. But how do I stop? Well, bizarrely, and I apologize, I'm running over again, but we got a late start. How do I stop? Well, I stop when it is possible to unify the last move with 1, 1, 1, 1. So bizarrely, as I set this up, I'm going to just be, I will add a new move, and then the next thing that's going to happen is it's going to attempt to basically solve the thing and say, and at the start, and say, can I get everyone across? So I'm going to start out, I'm going to have some everything must be on the left-hand side. And then obviously I can't get to 1, 1, 1, 1 in one move because only one of the things could move. And then, but these constraints are going to get looser and looser and looser, and eventually we find a solution. So strangely enough, this base case works. Questions about wolf, sheep, and cabbage? And I will paste this into the Slack so people can play with it. So, are there questions? It's mind blowing. It's at first very counterintuitive even if you've been doing Prolog programming. But it's very, very powerful. Constraint handling rules, in fact, was originally written to make writing new constraint systems easier. But the idea that you can just kind of keep constraining things until eventually you get to where you can label them is just pretty crazy. More comments, questions? How it restricts the length of the path. It builds up the path one step at a time. I'll illustrate. Let's try an experiment. Let's force the new position of the wolf. Let's never haul the wolf over. So that this can't succeed, obviously. And now what it's going to do, I hope, is it's going to blow the stack. Yep. Okay, why? Because it can never find a way. What you're saying when you do unification is you are restricting the domain of a variable to a single value. That's what grounding a variable is. An unground variable has an infinite domain. A ground variable has a single element domain. And if you attempt to unify and you fail, you have a zero element domain. So this expands the idea of unification. What's it useful for? Lots of things. You've got an assignment to watch a video and then kind of take a worked problem and extend it to figure out Susie's problem with her high school love life. You can imagine that there are serious problems that look like that, like problems of game theory and international relations, business. Would it find a path of longer length? It will, because this is basically deliberately allowed to blow through the base case. Notice that there's no cut on the base case. Okay. Well, folks, this is our last lecture, and I do apologize for all the confusion getting started. But it's been lovely having you guys in this class. This has been great fun for me. I hope it's been fun for you. I hope you've enjoyed it, felt like you learned something. It does give all the solutions. You can see here I ran it several times. And you can just see by the way it lays it out that it gave some that are longer. In what ways is Eclipse better at CLP than the CLPFD library? Yes, for one thing, Eclipse has a richer set of these predicates. For another, the way CLP works is, let's constrain. If we say x must be greater than 5, and then we say x must be greater than 7, it says x is going to be in 8 through infinity. I tell you what, hang on. I'm going to say x in 1 through 10 to make this more obvious. Okay. All right. So I constrain x into a domain, and then I insist that x be more than 5, and then I insist x be more than 7. Notice that all I've done is made x have a smaller domain. And, you know, I can, CLPFD is very clever about this. Let's go back all the way to this one that we started with, and notice that it cleverly realizes that y must actually be 1 less than x. So it can do some pretty crazy, amazing stuff with restricting things. I was surprised to learn that it will realize that 2-bit operations can never both result in the same bit being set, and we'll just make that bit be 0. um, so, okay, yeah. So back to so. Um, so yes, the eclipses is better than CLPFDs, basically because it has more of that intelligence, and this intelligence is really important. Not so much at this level, but when you get lots and lots of constraints, what you're doing is you're reducing the size of the problem space. So writing things in CLPFD oftentimes makes them run really fast. Um, One of the examples is called quarreling children, and if you run quarreling children, um, it runs fairly fast. Uh, I suggest you try just kind of naively solving that without CLPFD. Uh, it doesn't appear to be that big a deal, but it's 16 factorial, uh, and it's extremely it's not tractable. Um, so without CLPFD, but it runs fast with CLPFD. Okay, well, I've enjoyed having you. This will be our last sync event, and uh, the and I really appreciate everything you guys have done. We will. I will be. The class doesn't officially end till Saturday, and I'll be helping people, and we'll be chugging away until Saturday, try and get as much as you can in. And after the class, I will leave the Slack up, and I'll be perhaps less available, but I'll be around, and I will leave most of the stuff up. At some point, I'll bring the virtual world down when we start our next class, because that will require um, uh, that will require me uh, needing that server that it's on for something else compute intensive. But everything else will remain up. And hang on, I think Ian has something for us. Boom. Okay, and I guess Ian has what I suspect is the feedback form. So, so everybody, please do give us the feedback. That's the only way we can improve these classes, and the only way we can have more Prolog is to have more Prolog programmers, and the only way to do that is to make these classes as good as we can. So. No, Charles asked, will we cover the last? No. Frankly, things ran slower than I expected, and we dropped that last module. It was a kind of quick smorgasbord of basically of things I knew we wouldn't get to. I gave a talk called On Beyond Prolog for the Munich Lambda users group, or Munich Lambda or something, and it covers much of that material. So, yay. One thing I would like to hear from all of you guys is kind of what else you'd like us to do here. We're kind of we're having great fun giving these courses and would like to give more of them. So if people have suggestions, tickle my ear, let me know. And I was going to put out a feedback form. Yay! I'm glad everybody's feeling like they learned something. This was an experimental course. This is we gave a somewhat similar course in 2018, and then this is the first time it's being given, so I know there were a few rough points, and we're still learning how to do this. Great. I enjoyed having you all. Thank you. Yeah, Norbert and Don, I really appreciated all of the great enthusiasm you had for the course in particular. Um, yeah, like to see the SimWorld course coming together. Yeah, put all the stuff in the um, in the feedback form as well, because that very much will influence us. Yeah, the SimWorld was. Yay! Yeah, and Norbert, I'm sorry I haven't done a thing on Firo, um, but I've been busy. You see, I'm teaching this online course. um, so yay! And uh, we're going to do a course on chatbots. That's coming up soon. I don't know if I'm going to get in trouble with Ian for that, but I guess I'm going to let the cat out of the bag, and we're doing a chatbots course. We'll talk about making conversational agents. Yep. And I think that's the same. Yeah, that's the same form that was posted before. Okay. Well, thank you all. I'll see you back on Slack. And I think with that, we can terminate the stream.